Bismillahirrahmanirrahim. Assalamu alaikum students. This is your 8th lecture of physics for 10th class. In this lecture we are going to discuss unit number 11, that is sound. The learning outcomes for this lecture are the last topics of chapter number 11, that is noise pollution, importance of acoustics, audible frequency range, and ultrasound. Now, in order to discuss our first topic, that is your noise pollution, first of all, in order to understand noise pollution, we are going to discuss what actually is noise and what is your musical sound. Musical sound are those sounds which seems pleasing on hearing. Means when you heard those sounds, it create a very pleasant, a good impact on hearing. For example, the sound of a guitar, the sound of a piano, or the voice of your friends or your mother. These sounds are also known as your musical sounds. In fact, in short, musical sounds are those sounds which create a very pleasing effect on hearing, are called your musical sounds. Similarly, when we talk about the noise, those are the sounds which produce a very jarring or a bad impact on hearing, on your ear, are known as your noises. For example, the slamming of the door, the noise of the traffic, likewise the horns of the buses or cars or hooters of the ambulances, loud music, air traffic, all things create a very bad impact on your health. Similarly, you can see that there are two different nodes or the waveforms. One is your musical waveform and other is your noise waveform. As you can clearly see in the picture that the waveform formed for the musical wave is created in a very smooth manner, and it is a very smoothly drawn wave, a very smooth wave with a regular pattern. Whereas when we are going to see the noise one, we will see an entirely different pattern in which there is an irregular and a sudden change, sudden vibration, sudden irregularity, which create a noise or unpleasing effect on hearing it. This is the major difference, or this is the major cause of creating the noise pollution, and it is the major difference between noise and musical sound as well, which is a very important short question, that what is the difference between noise and musical sound. Now I am going to discuss the major issues of noise pollution. Nowadays, noise pollution has become a major issue in the big cities. As you already know that noise is basically an undesirable sound that create a harmful effect on the human health as well as all the living species. As you can clearly see in the both animations, that in the first animation you will see that for the construction in the big cities we use heavy equipments or heavy machinery which create a lots of noise over there. Similarly, you can see in the second animation that there is a noise meter in the animation which shows an alarming situation of noise pollution in the big cities. The noise of the traffic horns and the noise of the air traffic, it creates a hell for the living organisms, and it will also create some bad impact on the health as well, which I am going to discuss it later on. As you can see in the animation, these are not the only voices which creates the major issue or noise pollution. There are other things, that the machinery used in the industrial area, the loud horns of the vehicles, hooters, and the alarms that you used are also cause the noise pollution. Now the negative impact on the human health. What are the negative impact on the human health? Noise pollution can create negative effects on the human health, as it can cause the conditions such as hearing loss, sleep disturbance, aggression, hypertension, high stress levels. Noise can also cause accidents by interfering with the communication and warning signals. As you can clearly see in the animations, all these aggression, hearing loss, and sleep disturbance clearly. Now there must be some safe levels which you have to follow if you are working in the industrial area. That a safe level of noise depends upon two factors: the level of noise and the period of exposure to the noise. The level of noise recommended in most countries is usually 85 to 90 dB over a 8-hour work day. For a day, your noise pollution must be 85 to 90 dB. If you are crossing this limit, then it will affect your body organs as well. Now, how to reduce the noise pollution? Noise pollution can be reduced to acceptable level by replacing the noisy machinery with the environmental friendly machinery and the equipment, putting sound reducing barriers and using hearing protection devices. Now our next topic is importance of acoustics. The techniques or method used to absorb undesirable sounds by soft and porous surfaces is called acoustic protection. Now the question arises that why do we need acoustic protection? It is because the fact that when sound is reflected from a rigid surface, its reflection is more prominent and less if the surface is soft and irregular. Because soft and porous materials, as you can see in the figure, such as draperies, rugs, absorbs the large amount of sound energy and thus quite the echoes and softening the noises. So that is why it will lower the noises and it will give you a very soft impact of the voice. As you can see in the animation, that a sound wave strikes the soft and porous material and maximum sound wave is going to be absorbed here, and the reflected sound wave is less intense as compared to the incident sound wave. So it will basically softening the sound wave, so it will create a very good impact on hearing. Now sometimes what happens when the sound wave reflect, it will reflect more than one time. So when a sound wave reflects more than one time or more than one surfaces, it will grumble. When it will grumble, you are not able to hear that sound. As you can clearly see in the animation that when the person starts to speak, its sound wave strikes the rigid supports or the walls and they will reflect more than one times. When these reflected wave enters inside the mic, it will create a grumbled effect. So you are not able to hear the grumbled voice. This is due to the effect of multiple reflections and it is known as reverberations. So in order to keep this thing in mind, we have to design our lecture halls, auditoriums or theatre halls, and we have to take a balance between reverberation and absorption so that you can hear a very clear voice. In order to give a very clear voice to the audience, what we are going to do, we are going to place some reflecting surfaces behind the stage so that it will direct the sound to the audience. after reflection. Now, what is the importance of acoustics? Generally, the ceiling of the lecture halls, conference halls, and theatre halls are curved so that the sound after reflection may reach all the corners of the halls. Similarly, sometimes curved soundboards are placed behind the stage so that the sound after reflection distributed evenly across the each corner of the hall and you can hear the voices clearly. Now our next topic is audible frequency range. This is basically the range which you can hear without any pain. The range of the frequencies which a human ear can hear is called the audible frequency range. For a normal human ear can hear a sound only if the frequency lies between 20 to 20,000 hertz. Different people have different range of audibility. It also decreases with the age. Young people can hear sounds of 20,000 hertz, but old people cannot hear sounds even above 15,000 hertz. Now my next topic is ultrasound. Sounds of frequency higher than 20,000 hertz which are inaudible to normal human ear are called ultrasounds or ultrasonics. As these sounds are more than the audible frequency range, so it carry more energy. Similarly, as they are more energetic, then according to the formula V is equals to F lambda, the wavelength of the ultrasonic wave is very small. As its frequency is high, its wavelength is very small. So it can be useful for detecting the small objects very easily. Due to the characteristics, ultrasonic waves are used in medical sciences in order to diagnose and treat different ailments. For the diagnosis of different diseases, ultrasonic waves are made to enter in the human body through the transmitter. These waves are reflected differently by different organs, tissues, or tumors. The reflected waves are then amplified to form an image of the internal organ of the body on the screen. Such an image helps in detecting the defects in these organs. As you can see in the picture, that different doctors are going to view the human body onto the monitor with the help of a transmitter. Powerful ultrasound is now being used to remove the clots formed in the arteries. Ultrasounds can also be used to get the picture of the thyroid gland. For the diagnosis purpose, germs and bacteria in the liquid can also be destroyed by using high-intensity ultrasonic waves. Due to the characteristics of the ultrasounds, it is also used in the technical field as well. As you can see in the animation, that ultrasounds are also used to find out the depth of the ocean, as well as it is used to locate the objects lying deep on the ocean floor. This technique is called sonar. In this technique, the sound waves are sent from a transmitter and a receiver collects the reflected sounds. The time lapse is calculated knowing the speed of the sound. In the water, the distance of the object from the ocean surface can be estimated. By using these informations, ultrasounds are also used to check the cracks on the surface of the heavy speed vehicles. Sonar ringing is also used to see the shape and the size of the objects. Cracks appear in the interior of the moving parts of high-speed vehicles or machines such as turbines, engines or ships and aeroplanes due to excessive use. These cracks are not visible from outside, but they can be very dangerous. Such cracks can be detected by ultrasounds. A powerful beam of ultrasound is made to pass through these defective parts. While passing, these waves are reflected by the surface of these cracks and flows. The comparison of the ultrasonic waves reflected from the crack and form the surface of these parts can give a clue of the extension of the cracks. As you can see in the animation, that by sending a ultrasonic pulse, it will reflected and refracted at the inner wall surface, and then after reflection at the external crack, receiving the surface echo. After receiving the echo, it will also receive a crack echo in the red line. So in this way you can deduct the presence of the crack on the surface. Now by the end of my lecture, I'm going to give you some practice questions, that is the review questions of your book. What is the audible frequency range for the human ear? Does this range vary with the age of the people? Explain. Explain that noise is a nuisance. Describe the importance of acoustic protection. What are the uses of ultrasound in medicines? Inshallah, we will discuss the exercise of unit number 11 and 10 in the next lecture. All your MCQs and your conceptual questions are going to be discussed in the next lecture. I hope you will enjoy this lecture. Until the next lecture, Allah Hafiz.